So good morning, everyone. I'm very glad to be here. The one thing he forgot to say about me that's very important is I'm not really a morning person. I get better as the day progresses, but I hope I'll do. So to give you a little bit of background about me, I really got hooked on data when I took a course by a professor at CU Boulder, who then went on to become chief scientist of Amazon. So that was back in 1995 when nobody was really talking about big O data. And after that, I went to get a PhD in New York at the New York University Stern School of Business. I spent a couple of years at the IBM research lab up at Watson in the predictive modeling group before I joined a startup in New York doing digital advertising. So talking about the big data revolution, there's sure a lot of buzz about big data these days, and it works very well. I mean, I would have never guessed that this would be pronounced the sexiest job, but you know, I guess I got lucky. But preparing for this talk, I was thinking, well, what has really changed other than it just got really buzzy, and is there a revolution out there? Let's face it, data has been around always. And people were always excited about data. Maybe not as many people, but there was always excitement about it. I remember myself being part of a group that had to develop the global technology outlook for IBM back in 2007, and it was about data analytics. So that sure is not new. It has gotten bigger, that I give you, but the reality is it was always getting bigger. It was always that the data we had was more than the data we had last year. So that has accelerated maybe, but if you ask me what the key change really is, I would say it's granularity of the data that people actually work with. Now, what do I mean by granularity? Forget the somewhat cheesy picture. Think about the person you first fell in love with, and then try to explain to your neighbor why you fell in love with that person. Was it because she was blonde and athletic? Or was it the way she responded very quickly when you first showed her your collection of, I don't know, superheroes in your basement? What makes us who we are, and what people remember about us, is the action we take, is how we behave, is the things we do. It's not how you can describe somebody else. It's what makes us. Are our choices. And what I see for the first time over the last 15 years is now I'm getting to work on that level of information. I can see what people do, really highly granular, and that makes it very exciting to me. Now, before I get into my personal war stories about the data revolution, can I get a show of hand of who knows what predictive modeling is? Who has worked with predictive modeling before? Okay, that's not as much as I hoped, but still, it's a technical conference. So here's the very short of what I learned over the last 15 years. It's all about one thing. You take a bunch of data, and it needs to look somewhat neat, so we'll not spend too much time talking about this. And it's all what I call function approximation. There is some specific quantity you're interested in. Say, will they respond to my offer? Will something work faster? How much money am I going to make on a certain transaction? So there is a quantity. How much is the IBM stock going to be worth tomorrow? I'd love to know that. What predictive modeling is, it takes past data about this and tries to learn that function that determines this one outcome you really want to know. So you use data to estimate a function. At the heart of all of it, that's what I'm doing. And all of the examples I'm going to show you kind of fall into that framework. Now, in order to tell you what I do, let's talk a little bit about display advertising. So I joined Media 6 Degrees 3 years ago. And Media 6 Degrees is in digital advertising. It's one of these infamous third-party cookie-based technologies that get some scrutiny these days. How does it work? And you're sitting on your computer, and you're browsing, whatever it is that you're looking at some point, you may come to a site, could be a blog, could be a tech site. If it is one of our data partners, so we have data partnerships, there might be what's called a pixel on that page, which lets Media 6 Degrees drop a third-party cookie on your computer. It means we can record the fact that you went to that site. Now, when I mean you, I don't mean you. I mean that browser, your computer, actually right now requested that site. We'll talk about this in a bit later. So what I see now when I dig around in my data, I see browsing histories of people over a roughly universe of 100 million different URLs. Now, that's not where we make our money, that's where we pay. How do we make our money? Usually brands come to us to sign up for campaigns, say running shoes, Nike. The first thing we do, we also drop a pixel on their homepage. Now we see who actually buys what we're supposed to be advertising. So we know what the people who went there and bought, filled out a QA, whatever it is. The last step is where we actually earn money, is by showing ads online. So we get paid by Nike for running media, meaning showing display ads. You might be browsing again, say you come to the New York Times, there is space for a banner ad. That's a real revolution that by now a huge percentage of these banner ads are auctioned off in real time through ad exchanges. That really came to rise over the last 2 years. That wasn't around when I started 3 years ago. So there is a request. At the moment the site loads on your site, there's a request sent to an ad exchange, and all the other advertisers like us get to bid. And we will know that it's you in the sense we get the identifier back so we can look up your browsing history or whatever it is we knew about you. And based on that, we'll decide, yep, that's a good idea. We'll bid 2 cents. And if we win it, then we get to show the ad. We're not interested in clicking. So the way the evaluation works here is we're going to watch and see whether after seeing the ad, you actually show up at the Nike homepage to buy a pair of running shoes within, say, a window of 7 days. That's called view-through conversion. So this is on a very, very high level, and I notably simplified the display advertising the way I see it, and there are many different components to it. This is the environment in which I'm doing my work. So from your perspective, what happens? At some point, we come across you, and we create a cookie, and then we monitor you. So the first phase, as I call it, we're just trying to find the best browsers or consumers to show ads to. That's the first piece of technology where I have to get active and build a predictive model, because I'm interested to predict who of the people who haven't been yet at the Nike homepage are most likely to go there. Here is the granularity of the data, and also I want to showcase how little we actually need to know or how little we need to understand for this all to work. We record where you do, so your browsing history really just gets hashed. I'm not even trying to parse the site you went to. I'm not trying to contextualize it. None of this is of any interest to me. I will just hash the URL. All I'm going to give you is a random identifier. I don't want to know that you are Tom Smith. Irrelevant. I don't want to know your demographics either. I just have to be able to re-identify you the next time I see you. Meaning you are the same whoever you are that you were last time. So you just get in your cookie a random number from me. That's all. That's all we're going to track. From then on, we're going to record these kind of hashed URLs browsing histories, and we're also going to record when you bought something from one of our campaign brands in order to see how well you relate to that product. There are some other details around cookie stats that I don't think are relevant. So this is the data we collect for about 100 million users, and there, if you count cookies, you always count very dubious things. So let's say there are really 100,000 real people out there that we can track, 100 million, sorry. And we see a part of your browsing history. Obviously, I don't see everything. I'm not Google. I'm just -6 degrees. We have to pay for data, so there's a limit to things here. I'm only going to see what you do if you come to a site where we have a data partnership. On average, we have on the people we track, these 100 millions, maybe 30 pieces of history of what you've done. So some amount of information. I want to point at the complete shift, and that comes back to the theme of granularity. How was advertising done? Well, the brand walked up to you and say, well, we really are interested in these affluent soccer moms. All right, fine, good. Where do I find affluent soccer moms? Let's go and find publishers or content that is consumed by this type of person, and then that's where we're going to advertise. So it was all looked at through this very narrow lens of a few descriptive features in the way brands thought about their audiences. What we are doing now is, I don't want to know anything about you. I actually don't care if you're affluent. If you behave like somebody who buys lipstick, I'm going to advertise lipstick to you. So I don't need to interpret this. I'm just going to look at these hashed URLs that you went to, and I build a predictive model that captures behavior of previous purchases, and I can use that to score you. So what do these models look like? And that's really kind of an abstraction. For those people who know about predictive modeling, what ends up happening, we build a model in something like 10 million dimensions. It's either naive Bayes or logistic regression. So it's a big model and unfriendly to manage. What you see here is kind of a way to think about it. Every of these bars is a URL. And either going to that URL increases your probability of then purchasing that brand product, or it decreases it. So we have to build these big models for every single brand over again. So it's not like one static thing. It kind of lives and breathes, and it gets re-estimated about every 3 days. And it has roughly, I show a very small part here, we prune it down typically to about 1 million dimensions. So it captures a lot of complexity of human behavior, not just the 20+ categories that people can describe their customers in. What happens then, the obvious, we use these models to score you. So you keep browsing and reading, I don't know, tech blogs. Maybe you go to a New York City marathon running blog. Chances are that blog got a really high score for Nike running shoes. Once you get there, your score as to how good a prospect you are for running shoes goes up, because probably you're interested to some extent in running. Now, I use this as an example. Note that the machine has no idea that this is running or a blog about the marathon. This is all just explanatory. What happens behind the scenes is completely agnostic of any of that. And at some point, you look like a good enough prospect, and we said, OK, we want to start showing you ads too, at which point we tell the ad exchanges, please forward any bid requests to us for that person, and then once we see the bid request, we'll bid on you. So that's just the core initial piece of how targeting on a very large scale of very granular data works today. So we built what we call these segments. We basically just rank everybody. We can score everybody, and we've just picked the top 1%. I have no idea what these people are. I couldn't describe them to you any better as you could describe the person you fell in love with. They're just somehow coming out of the ranking of our models by one of our many models as being good prospects for a specific brand. Now, after that, I said we get bid requests and we show ads. That piece is an interesting problem by itself. Before I go there, let's look at how well that works. This is a comparison of lift, meaning how much better than random does the targeting that I just explained to you do at identifying people who then go and buy at Nike. And the median is somewhere around 4 or 5. It turns out the more niche the product, the easier it is. It's really hard to advertise credit cards because everybody and anybody has credit cards. But if we have to advertise scrapbooking, well, that's really easy. There's a very strong signal here. So the performance depends, I think, more on how easy it is, not how easy it is, how inherently difficult it is to predict that human behavior. Certain things are just much harder to capture than others. I don't know whether I will buy pizza tonight. Right now, if you ask me, I have no idea. I mean, I really don't know what I'm going to eat tonight. I mean, you guys probably at the party. I have to head out to Atlanta, but I'll probably grab something at the airport. So I don't know yet. But when it comes to my hobbies, I have a very clear preference. I know I'm going to be riding my horse on Wednesday when I'm back because I have to, otherwise he gets really unhappy. So there are certain types of human behavior that are easy to predict, and others are much harder. And so you see that scale reflected in here. There are certain products that are much easier to predict who will buy them than others. Now, this is the next piece where we got started once the RTBs, meaning the real-time bidding, became the big player in the boom. So today, we show about 95 to 99% of our ads through real-time bidding systems. Again, that technology was really emerging as of 3 years ago. By now, it has completely taken over the industry. The way it works is anybody who has a display ad spot can submit that through the exchange, and then advertisers bid on it. It is supposed to be a second-degree victory auction for those who are interested in technical details. What is interesting to me, or relevant, is I have exactly 15 milliseconds to make up my mind. Now, I know for finance people that's a long time, but in advertising, that means I can't run any very fancy analytics here right now. I have to make up my mind quick, because otherwise I'm going to miss out on the auction. So these are the constraints put onto the system in terms of what I can build. You see some numbers here in terms of daily volume. We get about 10 billion requests a day. Out of those, we only submit bids for 300 million and typically show about 50 million ads a day. That's the scale of the operation. There are a number of these exchanges out there. In terms of the unique cookies we see, and that's, I mean, stable cookies, because people keep deleting their cookies anyway, and counting cookies is kind of one of these very undefined activities where you never know what you're really getting. So cookies older than 2 days, we see about 60 million unique cookies a day. All right, so what happens at bidding time? So far I just told you that I know I want to show an ad to you for running shoes, right? What exactly is the analytical piece for bidding? Well, the first question is, does it matter what you're currently doing? I know you're a runner. That has been established because you went and read this blog about the New York Marathon. But does it matter whether right now you're on kayak planning your next trip to Texas, whether you're on ChinaFlix doing, I don't know what one would do at ChinaFlix, or read the New York Times? Now, presumably there is better opportunity here or a worse one. So the next piece of analytics and predictive modeling is, how can we estimate the value of inventory and how can we price it accordingly? Obviously, it should matter somehow. It could matter because it tells me what you're currently doing, your state of mind. Are you in a shopping mode? Or are you thinking about running? I mean, so maybe a contextual match right now is actually useful. There is a lot of debate right now about visibility of ads, because believe it or not, the vast majority of ads actually never seen. Because they're either under the fold or invisible to start with. So what's called inventory quality should matter as well. So that's kind of a causal question. Can I actually influence it? Because you have to see the ad in order to be affected in your behavior. So what we are interested in here is to measure how much more relevant this inventory is. Meaning, is the probability of you going and buying these running shoes higher if I show you the ad here, as compared to any other place where I could have shown you the ad? So really, this is a simple ratio where I'm just saying, is this current piece of inventory, meaning the URL you're currently on when I'm trying to show you the ad, better or worse than what I call the average, any other opportunity I might have had? There are, again, two of these predictive models stuck in right here, and we have to build them for every campaign separately. To show you how this then comes out, it's a ratio that centers around 1. So 1 just means your average, right? So here I show you the scores for a hotel campaign. And not surprising, if you show hotel ads on a travel site, that's great. Nobody should be surprised. Less obvious, apparently social media or dating is not really relevant to book hotel rooms. So that's the spread. What are we going to do with this information? So we know that there are better places than others to show ads, right? We use that to price the auction. If I know you're a good prospect, but right now is a great opportunity, I probably should put some more money on the table to get you right now. So we have different bid strategies, and these are just the kind of three basic ones. Default is always bid the same price, which is, unfortunately, a lot of our industry is still not very performance-oriented. We're actually not paid by performance. So the way our deals work is Nike comes up and says, OK, here are $100,000. Go off and show a couple of million ads. And yes, we're going to look how well you're doing, and we'll decide based on that whether you get a renewal. But we're paid for volume. So initially, that just means that translates, once I take out my margin, to kind of a fixed price. What we are interested in is, can we either increase our margin by while delivering the same performance, or can we maybe, if it comes to the renewal question, improve our performance without necessarily blowing the budget? So the two strategies here, the second one is what we call value. If you believe in auction theory, and I don't believe really in auction theory, but it's a nice framework, the rule of the game is, well, second prize victory, you bid what it's worth to you. I just kind of told you that I don't know what it's worth, but hey, if it's usually worth $2 and right now it's twice as good, then I probably should bid twice as much, right? So we use this as a scalar on the bid price. Or if you really want to be aggressive, that's not what you really want to do. You only want to show ads to the good opportunities and not at all to the bad ones, even at a cheap price. If you really care to push performance to its maximum, you just want to go with the good opportunities. So that's what I call aggressive, where we're saying, if this inventory looks like it's below average, don't even bother bidding. And if it's above, then go in pretty high. So what are we going to look at? As I said, we really care about conversion rate as our internal performance metric, but the other one is how much do we pay for it? Because you can always get more performance by paying more, but as a company, that's not a good long-term strategy. So we're looking at cost per acquisition, which basically just means you take the total number of conversions and divide it by the amount of inventory you had to show for it. Here you see how these strategies work out, and pretty much as hoped for, the value strategy, this is all normalized now against the default of always bidding the same. The good news is both of these lowered the CPA, meaning cost per acquisition. So both of them do better on kind of a economic value metric. They actually also both perform better. So the first one's really free lunch. We get better performance at the same price, which also means we could maintain same performance at lower price if we wanted to. The aggressive performance, even better, gets much higher. Conversion rates also turns out to be more expensive. So that's kind of a timing issue. If we come up for renewal and we are being told that our competitors are doing a lot better right now, then maybe it's time to leave some margin on the table and try to push performance a little bit. Now, the really interesting question a marketer should be asking is, well, does it even matter? Because at the end of the day, what's the name of the game? I'm really good at predicting who would show up at the Nike homepage anyway. That's what I've told you so far. All the analytics we have built is try to find people who are most likely to show up at the Nike homepage. And yes, there's this leap of faith that you hope people who are more likely because they're runners are probably also more swayed towards going there by a Nike ad, but that's jury is still out there. So does advertising actually work? the classical way of thinking about causal analysis, which really this is, the question is showing the ad, does it change your behavior? If you want to do this right and you talk to a social scientist, the short answer is you need an A/B test. What does an A/B test mean? Well, it means that to some notable portion of your audience, you have to show public service announcements or some random other ad. Now, so you imagine me going up to either Nike or my CEO to tell him that I recommend that half of the campaign we actually should be showing random ads so we can measure the effectiveness of the campaign. It's typically not a very good proposal. So I think it's a very important question, but very few people seem to be truly interested in investing the time and money to get the answer. Now, what I learned over the recent past from one of my colleagues is if you have data that's granular enough and contains the information why you chose that person, so your decision is being accounted for, you can actually just use analytics on the data you anyway collected by running the campaign the way you would have done to answer causal questions. So that's for me a big leap that I hadn't really seen before, that big data can ex post answer causal questions without having to go through that tedious A/B test that costs notable resources. Now, let me explain where the difficulties are. This is Charlie, our intern, and when he gets bored, he likes to hang out and look at a couple of pictures and rate them. Okay? Well, you know, he actually likes her. And he's really bored, so he thinks about, man, I'd love to get her number. So what should I write in the message to get her number? That's a very causal question, right? You're trying to influence somebody's behavior here. Now, since he has some exposure to data science, he also knows there is this great OkCupid blog where they show very interesting analysis of their data. And if you go there, they actually recommend the last thing you should do is make compliments. So you shouldn't tell her that she's beautiful. Okay, on the sexy I agree, but why is that so bad? Well, the problem is beauty is confounding. It messes up your causal analysis. Imagine she's actually good looking, right? If she's good looking, then she gets a lot of requests for a number. And on top of it, she's picky, probably. So your chances of being replied to are pretty low to start with. Not because you said she's beautiful, because she is. So when you are tempted to make her a compliment, it also means because she is very good looking, your chances were much lower in the first place. So it looks as if saying that she's beautiful is a bad idea, not because it really is, because it actually has no impact, but simply because your chances were much lower for the good-looking ones in the first place. That's what we call confounding in causal analysis. And that's why it's not trivial to do that. Now, the same happens with advertising. Of course, I just explained to you the last, 20 minutes, all the hardships we go through to find out who's most likely to purchase the product, right? So I'm not showing ads to random people. I only show ads to people I know are more likely to purchase. So if you're going to simply compare the conversion between the people who saw the ad and those who didn't, because, hey, I chose not to show it to them because I knew they wouldn't buy it anyway, it looks as if there's a huge impact. But this is not causal analysis. This is not how you do causal analysis right. In order to get this right, you have to account for the fact that I picked you, that I chose you because I knew you're more likely. So you need a model, really, that has to be able to estimate what would have happened without the ad to the people that I pick, and what would have happened to the people I didn't pick had I shown them an ad. there are some technical constraints about when this works. This is not the way to do it. You need to have what's called targeted maximum likelihood. There are techniques out there now that you can use on observational data to get this right. Now, if you do this right, what do you see? To my surprise, actually advertising does seem to work, sometimes. So here you see the conversion rates in red if people didn't see an ad, and in blue if they had seen an ad. So these are predictions from models, not actual counts. And you see the lift that the ad has. Now, you see 2 bars for every one of them, because there's a major difference between retargeting and prospecting. We will get back to this. What's retargeting? It just means we already saw you at the Nike website. You have ever made this experience? You look at a product and you see ads for that for the next 3 weeks? Yeah, that's retargeting. So once you expressed interest, the probability of conversion is actually much, much higher, and that's why it's such a favorite strategy. It also doesn't take any analytics, let's face it. I mean, this is really trivial, right? So you see here that there's a difference between retargeting and prospecting. What's interesting that advertising here for company A, and it was a B2B, was much more effective on the prospecting side in terms of the relative lift. We got a lift of 4.23. Now, what you also see that it actually matters in the left case, they were doing good job at finding a creative that worked for prospecting. On the right side, they had a great ad for retargeting, but the same creative was doing very poorly for prospecting, which is a nice lesson to the people who design creatives. If you want to do prospecting, you have to tell me a little bit about your product, like something. It's not enough to just show me the logo. Whereas for retargeting, that might be enough because you just have to remind me of your existence, which is notably easier. So, and yes, we also see cases where we checked for bugs for a long time until somebody bothered to look at the creative. Mind you, this is a creative for a hotel chain. So I'll leave you with this little quote while I get a drink. So this type of ad, it's basically a decade of optimizing clicks. Make them flashy and a whole bunch of stars around them. Because for a long time, people were measuring clicks as a metric of performance instead of what's called view-through conversion, which makes things a lot harder. The reality in my business is clicks are absolutely random. We ran experiments where we actually built models to predict click. It's actually pretty easy to predict clicks. It's people with eyesight problems or on small handheld devices. Now, how many have heard of that recent story about botnets in advertising? So this story came out, I think it's a week now. And it has an interesting background. We observed this in spring 2012. Within about 2 weeks, some performance index, which is kind of an aggregate over all of our campaigns, 300 of them, doubled in performance. I mean, I'm pretty good, but not that good. And I didn't believe it. When we looked inside and tried to find out what's going on, we found these strangely predictive websites. Women's Health Base predicts buying cars, downloading Microsoft Office, applying for credit cards, buying pizza, and booking a hotel. All right, that's odd. What's going on? I don't believe that. So it turns out ComScore already had the statistics in 2012 that about 36% of all internet traffic is, they call it, well, we call it non-intentional. It's not just simply bots. They're actually sitting real people. I don't know why this is on autopilot, but it's basically taking over your browser while you're doing it. What has become different, what has changed is that now somebody figured out that this traffic should also go to regular sites. So instead of just trailing the women's health space and whatever else, now a lot of this non-intentional traffic goes to retail sites. Why? We just talked about retargeting, right? Once you have been at Nike, you are much more attractive for the advertiser because everybody wants to show you an ad for running shoes. So by sending people first to regular sites and retailers, the value of those cookies that then are shipped around these botnets goes up tremendously. Now, from Nike's perspective, you get a lot more traffic, but the reality is, if more than 30% of the traffic coming to your site is not really intentionally there, but just got forwarded by a botnet, then I would be very concerned about your web analytics at this point. Now, this is one of these sites that we spotted very early on. I mean, we had this one under the radar since 2010, Women's Health Base. It doesn't seem to have a lot of content, but it doesn't look outright suspicious. I mean, we're not talking about, really bad things here. I mean, there's much worse out there. So it's not what the site looks like that's deceiving, that is telling. What's interesting is if you look at the traffic patterns. Now, we are not in the business of finding botnets, right? That's not really my core value proposition here. But what I do see, if I look in the ad exchange, I get bid requests. So I know where you have been. So I'm getting these requests, and I can tell that people traverse very, very quickly from one URL to the next. So what I'm going to show you is data where we look at 50% overlap, where 50% of the people who went to one website within a short time period also show up at the other. So we're looking at the traffic patterns between URLs. This is what the world looked like in 2010. So every red dot here is a host name, and a link means that 50% of the cookies we saw visiting one also visited the other. Now, this is an example of a small structure in here, and that's actually the Boston Herald, and that's probably legitimate. So these are just people browsing in Boston, local interest, fine. I'm OK with that. I can believe that. Now, if we look at Women's Health Base, that was the site we early on were getting really concerned about. Yeah, it's right there. Just think about how much browsing these people must be doing to go to all these sites. I mean, really? 50% overlap. Now, if you really look at it, look at what they go to. So Women's Health Base, wrestling news, China on TV, really? That's a very diverse set of interests for a lot of people to have. So this is the signature that we see in the exchanges from these fraudulent activities. And that's what the world looks like in 2012, just the exact same metric, something we built. We haven't done this recently because we just started to scrub them. So now we don't even see all the stuff coming in. Yeah, I don't even bother to show you the actual names of the URLs anymore. So the thing is completely blown up, and you saw the article. I mean, they make $6 million a month. That's a pretty good business model. OK, when all is said and done, we basically put a filter in, said we don't use that data, that event data, to feed our models. We don't track people. We don't show ads there. And you saw that our performance index came back down once we started the cleanup. So within about 10 weeks, we came almost back to now. OK, fun facts. If the URL contains mom somewhere, it was 3 times more likely to be fraudulent. If it had arcade in the URL, it was 5 times more likely. And yes, there were arcade sites for moms. With that, I went through pretty directly, so I'll have plenty of time for questions. Yeah, let's open the floor and leave it to you.
Do multiple people using the same browser mess with your data models at all?
Absolutely. Yes, certainly. And also the same person having multiple computers or multiple browsers, same problem. Yep, it does. sorry.
How do you get, so you said that you get the data about the user before you actually make a bid?
Yeah.
How do you get that data?
So we collect data anyway, right? So we have a cookie on you, and we can see every time you come to a site that we have a relationship with. At some point, what happens is what's called a sync pixel firing between us and the exchange. There is an ID exchange where we just agree that the random number they have on you is the same one that we have on you. So we just agree it's the same person. So at some point when we both see you, there is this sync happening when from then on we know that you are the same. Like there.
Okay, so you don't care who this person is, the data point. At some point, though, given granularity, they are going to develop a fingerprint that's, well, every bit as unique as a fingerprint. What's that threshold?
So the question is, when do we get to the point, I mean, I may not care, but when we get to the point when we can re-identify people? Yes. There have been studies out there that I'm very familiar with on, it was called the myth of the double-blind review. At some point, academia had this boring exercise of deleting the authorship during review. And it turned out that for 80% of the papers, you could guess the first author with a 50% chance of being right. I think it's actually a good thing that these multiple browsers and multiple people on the same device can mess things up. I think we looked at re-identification. I probably need something around 50. Now there depends how niche you are. If you're very niche, then it's pretty easy to get you. I would say with around 50, I would get close to get the majority, have a guess at the majority. But the reality is, I can only try to re-identify the same unknown entity that I didn't really know who it was before. So right now, the way it looks, with our data, I'd be very happy to upload it to your computer tomorrow. I don't think you could do anything with it, the way it's doubly hashed. So you have the hash on the URL. You can't even figure out what it really was. And I have a hard time really figuring out what really went on under the hood. So I think there is, maybe the case is, you can do pretty cool and effective analytics being very remote and kind of walled without having to go anywhere close to personally identifiable information.
So there's no real economic incentive to, at least from where you sit.
I have no incentive at all to know who you are. I mean, none whatsoever. It wouldn't make my life any better. At some point, the question will be, we're often asked by agencies, well, like dual strategies, online, offline, mobile, video, all over the place. Then things become much more difficult, because then I have to reestablish that you are the same person in real life when you drive by that billboard, preferably. So at that point, it gets difficult. Right now, as long as I'm just happily living in my locally contained ecosystem online, it's of no interest at all.
Yeah. I would think a bigger challenge would be to identify a particular site or a particular placement would match up with your demographics. What kind of measurements or what kind of data do you get from a publisher that identifies what you would need to match to your demographics?
So the question is about matching up the people we identify to demographics. Well, my answer to this has been, honestly, you shouldn't even try to do that. I know you'd still try to do that, but you think you believe that you know the demographics of the audience that you want. But are you sure? Really? You may be surprised who's buying your products. And you're right, this is still a question we get asked by advertisers and publishers alike. The new kid on the block is, of all things, to use Facebook to validate demographics of audiences. And apparently, so far, everybody has failed to do so. I'm not sure whether that tells me something about the demographics on Facebook or the other demographics out there. So we do sometimes actually buy demographic data. It's not something we have. We don't use regular demographic at all. But we sometimes buy data, and then the brands can check whether the demographics of the people we identify completely ignorant of any of that, and how well it matches their demographic kind of target pattern. We can be on spot there. We typically are. Sometimes they learn that they have a customer group they didn't even know about. So sometimes there are surprises in that. But it's not something we regularly even try to do.
Do you use simulated data at all for your predictive modeling?
Do we use simulated data for the predictive modeling? We sometimes simulate data in the sense, well, it's the other way around. We use the predictive model to simulate. So the whole point of causal analysis is you want to know what would have happened if you didn't show the ad to the person that you did. So in some sense, the predictive model becomes the simulator. We also, at times, simulate bid strategies. So we're saying, OK, what would happen if I reduce the bid price by 80% across the board? What I can't simulate is what would happen if I increase it by 20%, because I don't know what I would have won if I didn't, because I only have data. So we do a little bit around simulation, I think not quite in the way that you were asking, but we can talk about this in more detail. So let me go over there. There were questions over there too, right?
You described this site like Women's Health Base or whatever it was called. So they recognized that they could make money by kind of exploiting the analytics that were being done. And now you've turned around and twisted them. Do you expect like an escalation in techniques between the two sides?
So they were very happily making a lot of money without us and our analytics. So that's kind of how we observe them long before it hits the news. So the way Women's Health Space works, what's a botnet? It basically hijacks your browser and make it generate HTTP requests to all kind of different URLs. Women's Health Space made a lot of happy money for a long time by just showing ads to people that nobody saw because they loaded into an invisible iframe or behind or somewhere else. So the traffic that went there wasn't real. It was all unintentional. And so far, it was unfriendly, but nothing really bad yet, until the botnet who runs that forwarding algorithm realized that they should also send their traffic before they go through that loop of wrestling news and China on TV and Women's Health Space to, say, chase.com. At that point, the price for advertising on Women's Health Space went through the roof because it became retargeting. And at that point, it killed my model. Well, it kind of looked great for a short while. So is it adversarial? Well, right now, there's a lot of turmoil in the industry after these series of articles got published. And there's a lot of pressure on the consortium who's running those botnets. We have been somewhat interacting with them before. I have some journalist writing some chapter about this, and he has been trying to get these guys on the phone. They were semi-responsive in the beginning and have gone dark very recently. So I think there will be a new scheme very soon. It's just the programmatic nature of having an exchange, the same way you have insider trading in finance. This is not going to go away. Maybe the next wave will be smarter than this, or smarter. They're pretty good. They manage to mirror click rates almost realistically. They just couldn't manage the traffic. And there were very few entities who could observe the full, and even fewer who had an interest to go after them. Because if you're on ad exchange, it's actually great. You get a lot of traffic, right? There's a lot of money being made. So there were a lot of players in the industry who had at least one or two good reasons why they should look the other way for a while. And that hopefully will go away now, but I'm sure there was something else coming. So,
what kind of tools do you use for technology of your platform?
So the question was about the tools we have, what our core technology is. So that's not really my area of expertise. The short of it is we have a Hadoop system that just basically stores all the event data, every single interaction we have, whether it's through the bidding, through one of our data partners or purchases. We have a Cassandra system sitting on the production side that does more of the real-time stuff when it comes to scoring people and bidding. I personally use Hive to pull the raw data out of Hadoop. And then I do some scripting, Perl or Python, whatever the choice of the day. The techniques for modeling here, most of these predictive models are actually reasonably simple. So we talk about linear models, logistic regression, some support vector machines, but even we have naive Bayes in there. The reality is, if the dimensionality is as big as it is, and we typically have very few positives, we have a couple of people purchased before the campaign, you can't really get very sophisticated, and I have all these constraints on very fast execution. So the advantage of linear models is you just look up the parameters in a very quick NoSQL store, and you just add them up and you're done. You don't have to evoke anything. So most of our predictive modeling technology is in linear modeling.
Do you use any location-based information to augment it with IP address?
So the question was about location-based information. We have some set of geo-targeted campaigns. So sometimes it even is a requirement. They only want us to show ads in certain DMAs, and then we have to use it. We have built models on geo as well. So just take the zip code and pretend it's just the same thing as the hashed URL. There's nothing really different about a zip code than about a hashed URL. It typically doesn't contain a lot of useful information about you. I mean, think about in terms of granularity. What does it tell me? I mean, it basically tells me some average over all the other people like you living in the same area. We haven't found it to be terribly useful. So we have it in there, but I don't think it carries the day. No.
If behavior is so important in your modeling, what kinds of behavior do you find are very impactful in your perspective?
Okay. So the question was what type of behavior we find being predictive. As always, the simple answer is it depends. Let me be more specific. We have different sites. We have some social media sites coming into our like features. We have a lot of blogs. We have retail sites. A lot of other stuff that I'm not sure I can even quantify. It really is reflecting the product. So one observation we have had, if the product is somewhat social, phones, say, then social media can be useful, meaning the profiles of the people you go to can actually be predictive. But for the vast majority of products we're trying to advertise, and we're running anything from travel, finance, even some packaged goods, what seems to be a better indicator is retail. I mean, if you are searching, like contacts, I mean, there are so many places now where you can buy contacts. We get like very clean patterns of people looking through all the different providers until they pick the one they're interested in. For hobbies, such as running, we found blogs to be really useful. So there are a lot of hobbies and blogs where people are both active, like they write about not the product, but the activity, as well as consume written by other users. In those cases, blogs can be extremely helpful.
So it's very like vertical oriented, the types of properties that you find?
I would say so. We hardly really look. We just basically throw everything in the mixer and hope for the best. Because we build roughly 5,000 models a week. It's not really, I have any time to look at any of them, even if I wanted to. So you basically just lay it out at the land and you hope for the analytics to pick up what's needed. That's just kind of the few cases where we did look under the hood, kind of cases, yeah, case studies.
So two questions. The first one is just, I'm curious about how you market yourself to these websites. I mean, clearly you have iframes or whatever you're using on millions of sites to track people's actual browsing history. And I wonder how if I were to put up a website, how would you get me to add you to my site? And then the second part is just, with your competitors, do you negotiate for certain very high quality sites for exclusive access to people, the history of people who visit their sites.
So the first question was about how would you be able to feed us information if you wanted to, if I get this right? And the second one about competitors. Here's what I do know about the data. A lot of it comes through aggregators, like sharing apps. So we don't really own the iframe or anything. That's not our core business model. So we are seeking out data providers, and some of them have sharing apps that show up in a huge number of different sites. So when you you build a site and then you have, I don't know, the Facebook and the Twitter and the whatever else button, some of them, neither of the ones I mentioned, are actually selling data or provide access through their data. So we don't really have the time and the patience to go out and selectively say, okay, this is good, nope, this one. So we just buy this stuff in bulk. And because we buy it raw, it used to be really cheap because nobody knew what to do with it anyway. So it still is pretty cheap. In terms of competitors, it's very, very different. A number of our competitors, for instance, if you think about Quantcast, I would consider them one of our competitors. They started out offering analytics. So you wanted their pixel on your site because you wanted them to give you good web analytics. So you voluntarily let them have all your data because their value proposition initially was not to do advertising based on your data, but to give you insights. So they have a great data model. They don't have to pay for it. They just have good established relationships through their original business model. And so it really varies. I cannot possibly establish, we are a small shop by all means, so we cannot possibly even ask for exclusive access, and it's really the scale that makes it. I mean, having 100 million is, across all the different campaigns, more useful, cheap, than having that one property exclusively at a high price that may only be useful for 2 or 3 products. Yeah?
So one of the themes of this conference, to some extent, is social responsibility. So at the end, when you lay your head down at night, do you have any visions of how the work you're doing is societally valuable? And I'm not trying to be cynical here. I'm curious whether you formulated, this really is good, or maybe the reasons besides kind of, profit component.
Okay, so the question was about my social conscience and the role that my work plays in that, and I understood you weren't trying to be. So I grew up in East Germany. Advertising wasn't allowed there. There was no advertising. I grew up completely without advertising. I'm personally not terribly enamored with it, but here's how I look at it. So this is kind of my day job. My hobbies include that I'm teaching 2 classes at New York University about data mining. Here's why I love my job. It's a great playground. It's the sandbox right now to figure out what works and what doesn't and how to do it right, because I can make mistakes. Here's the thing, I can actually sleep at night. If I was to work in, say, detecting breast cancer and diagnosis, it's a different question. What happens if I'm wrong? Well, I showed you the wrong ad. Big deal. So I'm not trying to make this too big of a statement. The reality is I really enjoy teaching. I really enjoy getting people excited about the opportunities of predictive modeling and data mining outside of advertising. For me, it's a great place right now to try out whatever I want. If I want to try a different technique, it's in production in 2 weeks. And I can play with it and I can see what works. In terms of, granularity, do I need context? Is personal information important for this? What's the structure of the problem that calls for this solution versus the other? So I personally think we are in a learning phase right now as to how to make this work, this whole big data, how to make it useful. There's a lot of kind of flashy visualizations that may or may not really, at the end of the day, contribute to anything. The way I see it, I consider us in a learning phase, and that's what I use that advertising platform for. And I considered my responsibility to teach others how to do it and have them hopefully tackle in a few years the bigger problems that I would like to be dealt with as well. I do engage with kind of social data hackathons on the side, but I don't think it's terribly effective the way it's done right now. So I have some bones to pick with these things, but that would be my most honest answer to the question. All right, one more. Who wants to be the last one? There's one over there.
How big is big? So how many observations, how many features or functions that you're using now that you would like to be able to use, that you think any more would be no help at all? What's the upper bound?
Okay, so let's talk. He wants to know how big really is. The current state of our modeling for like the big models, they have about 100 million features. That's the width of it. What's the number of records? The problem is there isn't any more I can get. There are only that many people buying running shoes on the Nike homepage. I can't make more people go there. So it's kind of, I have everything that there is. There's no more to be had. So I'm at the limit. I get maybe, I don't know, for the average campaign, we have between 10 and 100,000 quote-unquote positives, meaning people who purchase. Obviously, I can get a lot of negatives. We have these 100 million people floating around, so I can always get people who didn't buy stuff. I would love to have more people buy luxury cars online. Yeah, if you know how to get those, I'm all for it. But if you ask me about the more features, are there like more URLs I could add to my pool? I think there is more, like, it would be great if I could use the Audi pixel to predict BMW's intenders or vice versa. I can't, so that's kind of a rule of the game. So there are certain things that I know are informative that I can't use, but I feel I'm pretty close to the glass ceiling of where I can go for this specific problem that we're having here. And I would love to get more, but it's not that there is more, it's just there isn't anything else. So thank you very much for your attention.